All right, so using the fact that this definite integral from a to b of f dx represents the exact area, they are going to ask, and we want to set up some integrands. So what we're going to do for setting up the integrand is we're first going to notice the function that we're integrating. So that is going to become inside of the integram. Now, keep in mind that we need to be careful with the variable. The variable here is v, so we write v as the variable of integration. So we'll take this f of v, and then because the variable is v, we're going to use dv. Now, the bounds are going to come from the x-axis. So again, the bounds will always be on the x-axis. You notice here that you start at x is equal to 0 and you go to x is equal to 2. So we're finding the area from x equals 0 to x equals 2. So those are the bounds from 0 to 2. Now, our very next step is to simply plug in what that function is defined as. So it's defined from 0 to 2. The f of v is 9 dv. And then that becomes what we want to integrate. So they have like all these crazy variations of this problem, but when you look at it, the 0 to 2, 9 dv, I believe that is the only one that matches what we have. The order does matter for the bounds. You'll notice there's a 2 to 0 here, but in terms of the bounds, it needs to be the lower number, the smaller number, and then the larger number. So if you look at this next one, again, what you're going to do is you're going to start with this function inside of the integrand. So you will have the integral of 23 over 4x plus 19 over 4. You'll notice here that the variable of integration is x, so that's going to be a dx. And then we need our bounds, and our bounds are going to come from the smaller x value, which is -8 here, and then the largest x value, which is 7. So that becomes what our definite integral, this notation, will compute the area below this x-axis and then the area above this x-axis and add those two together.